Okay, we're going to go through problem 899, and both of these problems, A and B, have to do with the Pythagorean identities, which I'm going to remind you are here. And remember, in some cases, it's helpful to rewrite those or to solve for one part or the other. So if we go back to 899A, we have cotangent squared times secant squared minus 1 equals 1. We probably want to look at the more complicated side to simplify it. So we're going to look at the left side. And we know that cotangent squared is equal to cosine squared over sine squared. And then the secant squared x minus 1 is actually related to Pythagorean identities. So when we have secant squared, if we wanted to solve that for tangent squared, we would subtract 1 from both sides, right? So we see that secant squared minus 1 is equal to tangent squared. So using the Pythagorean identity, we can rewrite this as tangent squared. And then we know that tangent is equal to sine over cosine. And since it's tangent squared, it's sine squared over cosine squared. And when we multiply that times what we already changed cotangent to, we see that we can make some giant ones here. So we can make a giant one with cosine squared x and cosine squared x, and another giant one here. And so by simplifying those fractions, we see that 1 equals 1, and that proves that identity. In the second problem, 899b, we're dealing with the original Pythagorean identity of sine squared plus cosine squared equals 1. But of course, wouldn't be that simple. We have sine squared minus cosine squared. So let's look at this. Now we're looking at the first identity, not the second one. So in this case, let's solve it for sine squared. If we want to solve it for sine squared, we're going to subtract cosine squared. And so we see that sine squared is equal to 1 minus cosine squared. So let's use that idea back here. Sine squared, we said, was equal to 1 minus cosine squared. I can't make this little symbol alpha very well, so I'm just going to change it to x for the purposes of this problem. And then we're going to subtract what we already had up there, cosine squared x. And our goal is to prove that this is equal to 1 minus 2 cosine squared x, or alpha. And so when we simplify this in the next step, if we have negative 1 minus another 1, we have negative 2. And what we're adding together there, or subtracting together there, is the cosine. So we have negative 2 cosine squared x, and then we just have this 1 in front. And that proves what we were trying to prove, that they were equal to each other. So rewriting Pythagorean identities and using them in a different form than the original can be helpful in solving these problems.